Today we have job number 13274 and it's a MacBook Pro A1706 that doesn't have any power. When we plug in our ammeter to the USB-C ports, we have 5 volts on every single one. This board in particular does have 2 USB-C ports either side. So 4 in total. Both of them have exactly the same reading of 5 volts. We do have around about a 360 milliamp draw when we put in the power to the board. This component gets a little bit hot and this transistor gets extremely hot. This transistor was actually replaced by my colleague to see if that would work, as was this chip, but we still have the exact same issue. The other component that reaches around about 50 degrees Celsius is in fact the CD3215 chip here. Now in my personal experience, I've not handled too many of these chips. I've replaced a few before, so I know what they're like, but this one specifically has the glue around it, so I'm gonna have to melt that away first. Usually any other chip, you just quite simply, even this, I think, MOSFET next to it, whatever component this is, just lift it up. But if we do that with this, because of the glue that we have underneath, we risk ripping the small BGA pads that we have. I do just want to put a little bit of a hold on it because I'm just doing a little bit of digging further before I go ahead and just remove that chip. So the IC that's actually getting hot, I think, is the one on the back, I want to say, or is it the complete other side of the board? Yeah, so that the IC that's getting hot is over here. This one is reaching about 50 degrees Celsius, and the other side of the board, which is directly behind it, is reaching around about 40 degrees Celsius. Now, I'm just looking at where we have that transistor getting extremely hot, which is CPU side just down here. And if I zoom, well, I can't zoom out too much, but I'm selecting this line here, which is the G3 hot charger rail, I want to say, but that doesn't go to the chip that's getting hot, which is, again, this one over here. If I click on the first pin of this, it's PB bus G3 hot. That goes to this small resistor here and then through a little via on the board, I think. And if I again go over to this IC, it's not linked to it in any way, shape or form. We turn the board back around and we go to the third pin. This one is PP voltage in G3 hot, P3V3 G3H, and it goes to a little capacitor just above it, the MOSFET that was also getting a little bit hot, and a capacitor that is down here. But again, it doesn't go to the other side of the board to where this IC is, this side. So I'm in a little bit of a conundrum because we don't have a short on this transistor itself. It's just getting very, very hot. And the only other component that is getting hot is this IC here. So I'm probably going to head over to the repair wiki, actually the Lewis Rossman one, to see if anyone else has come across this specific issue of this component getting hot. So I've done a little bit more measuring on the actual board itself, and everything points to this IC. So what I'm going to do is just slowly get rid of this, the glue that we have around it. I'm not as experienced on MacBooks as I am with other electronics like consoles. So I've got my heat currently set at 300 degrees Celsius, and I'm just scoring some of this underfill so I can take the chip off, and then I'll clean the underfill properly. Rotate the board to make my life a little bit easier. What we don't want happening when we go to remove this is that it pulls up all of the other components because of the underfill that we have. That's why I'm scoring this now. Now we smash it with some flux and some more heat. It's slowly coming loose, but again, we're not ripping this off. It's the glue that's now holding this in, the underfill. There we go. Got it loose eventually. Wow. And now what I should be able to do is get all of this underfill off very slowly and gently with these tweezers. That cap has obviously moved, but that's fine. All this little underfill we need to get off in between all of these pads. It's not ideal. Luckily, we have no ripped solder balls, which is nice. It just goes to show that the underfill is what was keeping that chip on. Some of these will be a no connect, so the pads will come off. It does happen. If we can, just try and be as careful as we can. Get as much of this as possible removed. I'm actually only at 250 degrees Celsius now, by the way. I thought 300 might be a bit excessive. There's a pad, so we need to be super cautious. Okay, giving that a quick clean, give us an idea of where we currently stand. All right, a bit more to go. I'm thinking at this point we actually go over it with leaded solder and then wick it up to make these as flat as possible. Might make getting the underfill off a little bit easier. So I'm just going to add some flux. We're going to add the soldering iron and the leaded. Go over these gently. Nice, there we go. Not pulling up on the wick either, because that's how we're going to rip off the pads. I'm just letting the wick do the work. Let the wick do the work. Looks pretty flat to me, looks good. Now I'm just going to clear this flux up. I'm going to add some heat to make our lives easier. Coming with a cotton swab, whilst that's nice and hot. And now isopropyl alcohol and a toothbrush. Do we have any more underfill to get? I'd actually say we look pretty good, except for maybe this bottom corner. Because what we don't want to happen is when we put this new chip on, we don't want the outsides here to affect the positioning. Hence the reason I'm getting rid of the stuff that's down the bottom as well. Okay, there we go. I think that's really good. Okay, nice and clean. I'm not going to say the easy bit because, you know, it depends. The bit I'd say I'm more familiar with, putting the chip on. Tiny bit of flux. I'm not just going to leave that there, by the way, because too much flux is bad. So I'll soak up some of that and spread it around. There we go. Now we take our CD3215 chip. There is one little bit of solder that I just want to get down here. Okay, and again, sorry, flux. Our chip is already pre-bored, which makes this a bit easier. Line the chip up as best we can. Probably around about there, I want to say. Come in with our heat. Come off the heat. That chip is not going anywhere now. Now we smash it with some flux. And the chip should fall nicely into place. There we go, as you can see. It's just danced into place nicely. Oh, maybe not. It's going. Going to give it a little nudge. There we go. Nice. Come off that. Need to put that little cap back on as well. The one here. Add a tiny bit of solder to this pad if I can. There we go. Just put that little cap back. There we go. Just going to check on the components around the IC to make sure that they're not skew with, like these two up here. Put some heat on them. They should dance back into place. It's the one on the left that's a little bit wonky. Might have to give it a bit of a helping hand. There we go. And now a quick clean. Some isopropyl alcohol. Toothbrush to finish it off. Let's test it and see what draw we get now. I should mention we were only getting around about 5 volts as well. So hopefully we get 20, and that will give us a good sign that the machine is fixed. Let's test now. I still get the same amount of draw, unfortunately. What is getting hot on the thermal cam is this little cap here, which is one that I obviously just not reflowed essentially. I've done the one next to it, but I'm going to take it off and just see if that makes a difference. Check again with the thermal cam now. Now it's actually drawing 5 volts and about 50 milliamps, turning off, turning on, turning off, turning on. So I wonder if this cap was playing a part in it being faulty. So I'm going to replace this now. Okay, so now what happens is we get 5 volts on the ammeter. It goes to around about 50 milliamp hours and then it drops down. But there is no heat showing on this cap anymore. So this cap is fine. Supposedly this CD3215 is also okay. But I'm actually going to take it off. Does that look a bit wonky or not? No. No, it's not wonky, is it? So orientation-wise, it's fine. But, I mean, I did get these from AliExpress, so the chances of maybe 1 or 2 not working is extremely possible. I'm going to see if I have any other CD3215s that are in different packets. What's this one? That's a 17. That's a 15. So I'm going to take one from this pack. I'll take this IC off again. No underfill this time, so it'll be a little bit easier. New chip, correct orientation. Pin 1 is top right. Chip should now be soldered in place. Give it 2 seconds. Give it a little poke. That should be good. Right, now for another test. Okay, what happens now? Plugging in the ammeter. Do we still get 5 volts, 50 milliamps? It looks pretty much the same. 20 volts, 600, 800 milliamps. Okay, let's go. Sweet. All right. Maybe consider that fixed then. What? I'm going to try it on the other side of the board just to make sure. Okay, here we go. Other side of the board. What happens? Come on. 5. Yes. Okay, sweet. So we'll put the MacBook back together. I'll pass it back to my colleague, and then I'll record it. Hopefully working. Let's go. Result. Okay, here we go. So we have the MacBook Pro all put back together. We're about to push the power button and see if we get anything. I hear a chime. There we go. Apple logo. Obviously covering up the user. There we go. All working. Now, the CD3215 chips that I bought from Ali in that same strip packet, I've tried on a few other machines and they've not worked. As soon as I've switched over to ones that I've bought from the UK, they seem to be working. So I don't know if I just bought a bad batch. Again, unfortunately, I think it's easily done. It's been about 2 weeks since that repair and customer is extremely happy with the result. Something a little bit different. Thank you so much for watching and I will see you in the next one. Peace.